Hello everyone, welcome to my midterm exam video for the operating system course. Today we are diving into crucial role in the tech world, system administration. Imagine you are an IT administrator tasked with setting up a structure and secure environment for developers. In this challenge, I will guide you through essential Linux operations from directory management to file manipulation, permission settings, symbolic links, and even user names. Throughout this video, I will demonstrate step by step how to execute these tasks using real Linux command and analyze their effects. Let's explore how system administrator efficiently manage file structure while maintaining security and accessibility. So stay tuned and let's get started. The first step in setting up our workspace is creating a structured directory. In Linux, directories are created using the make directory command. We will create a main directory under /home/mahasiswa/ with my name and name followed by 3 subdirectory, document, code, and arsip. Type mkdir /home/mahasiswa/name _name /document code and arsip. Here, we use -p option to create parent directory if they don't already exist. The curly bracket allow us to create multiple subdirectory in one command. Now, let's verify that our directory structure has been created correctly by using the ls-l command. Type ls-l home/mahasiswa/name As you can see here, our directory structure is successfully created. Now that we have set up our directory structure, let's move on to file manipulation. This involves creating, copying, moving, and displaying file, and these operations are fundamental for managing file efficiently in a Linux system. We will start by creating a file named identitas.txt inside the document directory. This file will store personal information such as my name, student ID, and study program. Type echo -e nama class name /home/mahasiswa/name _ /document /identitas the text. Is used to print text in the terminal. The -e allows special character like \n to create new lines, and the greater than sign redirect the output into a file creating identitas.txt. Now let's verify that the file has been created successfully by listing the file inside the document directory. Type ls-l and file path. Now let's display the content of identitas.txt to ensure it has the correct information. Type, cat, and file path. Now we need to create a backup of identitas.txt. To do this, we will copy the file to the archive directory and rename it as identitas_backup.txt. Type cp space source file path. Slice identitas underscore backup dot txt. Verify that the file has been copied correctly. Let's list the file inside the archive directory. Type ls-l slice home. Okay, next we will move the original identitas.txt file from the document directory to the code directory using the mv command. Type this mv move a file from one directory to another. The first parameter in the source file, identitas.txt in document. The second parameter is the destination directory folder. To check whether the file has been moved, let's list the content of the code directory. Type Okay, at the same time, let's confirm the file no longer exists in the document directory. Type L. Finally, let's check if our backup file in the archive directory is still intact by displaying its contents. Type chat and file path. Okay, as we can see here, the backup file still contains the same information as the original file. In Linux, file permissions are crucial for controlling who can read, write, or execute file. Each file and directory has three types of permission: read, write, and execute. These permissions are assigned to three categories of user. First, owner, which is the user who create the file. Second, group, which is a set of users who share permission. And others, which is all other users on the system. Now we will modify the permission of identitas underscore backup.txt so that the owner can read and write, the group can only read, and others have no access. Type chmod space 640 and tab. Here, the number 640 represent the permission setting. 6 means the owner has read and write permission. 4 means the group has read permission only, and 0 means others have no access. Next, we will change the ownership of this file so that the user is root and the group is staff. Type chown root and open. Okay, now let's check whether the permission and ownership have been applied correctly using the ls-l command. ls-l and open. The output, as we can see here, the file is now owned by root, belongs to the staff group, and has the correct permission setting. Symbolic link or symlink is a special type of file that acts a shortcut to another file. This is useful when we want to quick access to a file from different location without duplicating it. Let's start by creating a file named referency underscore name.txt that contains some text information. Type echo dan file tab. Slice mahasiswa, slice ini, underscore nama, slice referensi underscore name .txt. Now we will create a symbolic link named shortcut underscore name.txt that points to this file. We use the lm-s command to do this. Type now let's check whether the symbolic link has been created by listing the files in the directory. Type L. If we modify the original file, the change will also appear in the symbolic link. Let's test this by updating the content of referency underscore name.txt. Type chat, slice home, slice mahasiswa, slice in, underscore name, slice start tab, underscore name, .txt. As we can see, the symbolic link automatically reflects the change made to the original file. The user makes or you makes determine the default permission for your file. By default, Linux assigns for permission read, write, execute to new file, but the Unix value restricts some of this permission to ensure security. Let's check our current Unix value. Type Unix. Now we will change the Unix value to 0 to 7, which removes write permission for the group and all permission for others. Type Unix 0 to 7. After setting the Unix, let's create a new file name data_name.txt. Type launch. Now let's check the file permission using the ls-l command. Type ls-l. Okay, as we can see, the Unix value has influenced the default permission of the new file, making it more secure. And that wraps up our journey through Linux system operations. We've explored directory structure, file manipulations, permission settings, symbolic links, and user max, each playing crucial role in system administration. Through this process, we've not only learned how to execute commands, but also understood their impact on security and efficiency. Mastering this skill will give us a strong foundation for handling real-world system operation. So, keep practicing, keep exploring, and never stop learning. Thank you for watching, and I hope this explanation helped you understand Linux better. If you have any questions, feel free to ask. See you in the next one.